Lesson 12.5, Mean as Fair Share and Balance Point, is found on page 491 of your big book. Our essential question: how does the mean represent a fair share and a balance point? So we need some materials. So these little red and yellow counters, which I have ready. On an archaeological dig, 5 students found 1, 5, 7, 3, and 4 arrowheads. The students agreed to divide the arrowheads evenly. How many arrowheads should each student get? So even though this kid only got 1, the rest are going to share so that everybody has the same number. We're going to use counters to show how many arrowheads each of the 5 students found. Use 1 stack of counters for each student. Remove a counter from the tallest stack and move it to the shortest. Keep moving counters from taller stacks to shorter stacks until each stack has the same height. Count the number of counters in each stack. All right, and the counters in each stack is called the mean or average. So here we go. We have 1, okay, so 1 kid gets 1. Whoops, I'm off the screen, sorry. Another one gets 5. 1, 2, 3, 4, 5. Another kid gets 7. 1, 2, 3, 4, 5, 6, 7. Whoa. Okay, this one gets 3. 1, 2, 3. And the last one gets 4. Okay, so my stacks are all different heights. And I start moving from taller stacks to shorter stacks. So this one, the 7 one, gets shorter, but now it's the same as the 5. Let's see, this one's shorter. Let's give them another one. So this one has 4 and 4, 3 and 4. Okay, so now they're all even. They're all flat. And this one has 4, 4, 4, 4, and 4. So if they share counters evenly, each of these 5 students will get 4 arrowheads. All right. The number of counters in each stack is the mean or average of the data. The mean represents the number of arrowheads each student should get if the arrowheads are shared equally. There are 5 stacks of 4 counters, so each student should get 4 arrowheads. All right, let's answer this next part. Explain what is fair about a fair share of a group of items. Basically what that means is no one person is going to get more than the rest. No one person is favored over anybody else. So when shared fairly, each share is the same size. In this case, everybody gets 4. Everybody gets the same size. Okay, how could you find the fair share of arrowheads using the total number of arrowheads and division? Okay, so let's take our data. We had a 1, a 5, a 7, a 3, and a 4. If we add all of those up, 1 plus 5 is 6, plus 7 is 13, plus 3 is 16, plus 4 is 20. So 20 arrowheads were found. There are 1, 2, 3, 4, 5 students. So if I divide, if I divide 20 by 5, it's 4. It's the same number as we got up here. That's when we get into bigger numbers where we can't use stacks of little circles to figure it out. This is the faster, easier way to figure it out. Okay, let's see. So I add all the arrowheads found and divide by the number of people. And that will also give me that same number 4. Okay, let's take a look at the next page. The mean can also be seen as a kind of balance point. Mrs. Burnham's class holds a walkathon to help raise money to update the computer lab. 5 of the students walked 1, 2, 4, and 7 miles. The mean distance walked is 3 miles. So complete the dot plot for the data. So 1, 1, 2, there are no 3s. We have a 4 and a 7. All right. Circle the number that represents the mean. Well, in this case, it's 3, they told us. Right here. Complete the table to find the distance of data points from the mean. All right. Values less than the mean, 1 and 1 and 2. So these 3 numbers, 1, 1, and 2, are all less than the mean. So 1 plus 1 is 2 miles. Distance from the mean, 2 miles. But there's only one of them that did that. I don't know why they want me to put a 2 here. So 2 kids went 1 mile. One student went 2 miles. Here we go. Greater than the mean. I have 4. Oh, I get it now. I'm not looking at it right. Okay, so these are our data points. 1, 1, 2, 4, and 7. Okay, so those are our data points. 1, 1, 2, 4, and 7. All right, now distance from the mean. Oh, I see. Okay, so 1 here is 2 spaces from the mean. Let me do this. So this kid walked 1 mile. That's 2 spaces from the mean. That's where that's coming from. Another kid walked just 1 mile. That's 2 spaces from the mean. Another kid walked 2 miles. That's 1 space from the mean. Another kid walked 4 miles. That's 1 space from the mean. 1 more than the mean. And this one walked 7. That's 1, 2, 3, 4 spaces from the mean. Okay, the total distance from the mean for values less than 1. So we have 2, 2, and 1. So that would be 5. And that came from here, here, and here. The total distance of the mean for values greater than the mean are 1 and 4, which is also 5 miles. So the total distance of the data values less than the mean is equal to, in this case, the total distance of the data values greater than the mean. The mean represents the balance point. So that will always be the case. It'll always be equal to, because this is the center. 3 is the center of the data points. The mean represents a balance point for data values less than the mean and greater than the mean. Okay, so explain how you found the distance of each data value from the mean. So basically I used the dot plot and counted the spaces, right? All right. Let's go a little further. I used the dot plot and counted the spaces from the value to the mean. Can all the values in a data set be greater than the mean? Explain why or why not. Okay, so if the mean is the center, is the middle number of all the distances, is it possible that they could all be greater than the mean? No, of course not. The mean would actually have to be up here to be in the center. The mean has to be in the center of all the values, it has to be between the lowest and the highest value. No. The mean has to fall between the lowest and the highest value. All right. Let's move on one more time. They want us to use counters again. Here we go. On the first day of the school fundraiser, 5 students sell 1, 1, 2, 2, and 4 gift boxes of candy. Make 1, 2, 3, 4, 5 stacks of counters with the heights 1, 1, 2, 2, and 4. All right, so I've got 1, 1, 2, 2, and 4. 1, 1, 2, 2, and 4. Rearrange the counter so all 5 stacks have the same height. Okay, so I'm going to give a couple of those away. Oh, well, that was fast and easy, wasn't it? They're all flat now. They're all the same height, and they're all 2. After rearranging, every stack has 2 counters, so the mean of the data set is 2. Okay, we're going to do this dot plot method one more time. Rosanna's friends have 0, 1, 1, 2, 2, and 12. Wow, that's a menagerie at their house. Pets at home. Rosanna says the mean of the data is 3. She says it's right here. Is she correct? The total distance from 3 for data values less than 3 is 3, this is 1, 2, 3, 2, 2, 1, 1. Okay, so 3 plus 2 is 5, 7, 8, 9. So 9. The total distance from 3 for data values greater than 3 is, well, that's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the mean of 3 is a balance point. Is that what they want us to say? Is a balance point. So Rosanna is correct. Okay, good luck with your PMT.